Hello guys, welcome to another session. In this session we are going to discuss about vectorization concept. So let's jump into the Jupyter notebook, and there we will discuss about the concept, and we will also do some example, and with the help of that example we will understand the vectorization concept. So we are into the Jupyter notebook. Now let's start our discussion. So what is vectorization and what is the purpose of vectorization? Why should we can use vectorization in NumPy? So guys, basically vectorization is used to speed up the Python code without using loops. So what does it mean? So let's understand with a simple example. Here I am going to first import NumPy as NP, and now I am going to generate two arrays. One is called A, and here I am going to take help of a range function, and over here I need to specify a range over here. For example, I'm going to specify 0 and 5, and there is another array which I am going to generate, and I want to add both of the array. So how do I can add it? So if we will go through the loop, then what will happen? It will iterate through all the elements from array A and from array B, and then do the addition operation. So let's do it with the normal way of addition. So how do you will do that? So let's create an array for holding the result, and over here we need to do a loop. For that we are going to use for I in range, and over here we need to specify the length I want. It will execute till the all the element is being read. So length of an array A, and over here we need to do the addition, and that result will be kept inside the result array. So that we will tell that res happened, and over here we need to specify over here then B. Within that I'm going to specify I, so all the same position element is being added. After that, this is basically a Python list, so we need to convert it as an array. So we need to tell that np dot array, and within that we need to pass this list. So now it becomes the array which is of NumPy. So now let's execute it. Shift enter, then you will see that it has added both the array with their respective position. For example, at the 0th location it is having 0, and 0 plus 5 is 5. So let's print it so that it will confirm print A, and over here print B. Now shift enter, and if you will add both the array, then you will get this result. But the problem with this operation, it is very time consuming. This array is very small, but when you are going for data operation, which is basically in machine learning or any of the data analysis which you are performing on any of the array, then this operation is very costly affairs. I will show you the performance difference, but first let's look into how we will do the same operation with the vectorization technique. So NumPy offers us various methods, and that we can easily use to perform such kind of calculation. For example, if you want to add two arrays which is of similar size, then you just need to add A plus B, and it will perform the same activities whatever you have done with the help of this loop. And you do that, and over here let's print the result also. So first let's shift enter, then you will find it over here. It is returning the same value, and the execution time is drastically different. So let's compare it. So to get the execution time, we are going to use some magic function which I have discussed about earlier, that is called time it, and shift enter. Then you will find that it will return us this is the amount of time it has taken to execute this program. And now let's look into what is the time it is being taken to execute the vectorized operation. Shift enter, and you will see the difference that is drastically lesser than this loop one. And here you will see that the loop one is taking 1.87 microsecond, and instead of that it is just taking 738 nanosecond. By the way, if you are not aware about the microsecond and the nanosecond, the microsecond is 1000 times of nanoseconds. That means 1 microsecond equal to 1000 nanoseconds. So we can perform any kind of mathematical operations on two arrays without using the loop. Earlier we used to do this operation with the help of loops, and that is very time consuming. But within NumPy it has given us the flexibility so that we can directly use the normal operator on the arrays, and that will perform the required operations. Suppose if you want to perform the multiplication of two arrays, then you will get something like this. So what it did, it has multiplied the 0th position of A array with the 0th position of B array, and same for the other element. So it multiplied 0 into 5, that is 0, 6 into 1 6, 7 into 2 14, 8 into 3 24, and 9 into 4 36. And if you see here, it has returned the result. Same thing, you can apply the division operation, and this is all the vectorization technique, and that is being used within the NumPy. And if you try to do the same operation in normal Python, then you will find that instead of doing the addition and all this, what it will do, it will just concatenate the list. For example, suppose that if you are having a list called C, and here you are having some element 0 1 2 3 4, and the same if you are having C and D, let's paste it D, and this time you are having 5 6 7 8 9. And now if you try to add these two lists, then you will find that instead of doing the mathematical operation, it is just doing the concatenation operation. So let's look into that, and you will find that it did the concatenation instead of mathematical operation. So that's the reason it is very much powerful. NumPy is very much powerful because it offers us vectorization concepts implemented within the NumPy. And this is what I wanted to demonstrate you in this session. See you in the next session. Till then, bye bye, take care.